Hello, welcome back to Oracle DBA tutorial. In this tutorial, we're going to discuss about distributed transaction. So let's take an example, before we do anything. So we have this is the database one. So let's I call database one, and then I have another database, database two. And what I'm doing is that from my SQL prompt, I have now connected to this database one. Okay, so I have connected to db1 using DNS string and all those things, so that you know I have a dedicated server process running here in this database one. And then assume that we have a table T, and I'm connected to a user, say Scott and Tiger. In Scott, so Scott user and password Tiger. So and then in Scott user I have a table T. Okay, and so this is Scott user of db1. Similarly, I have another table, say T2. Again, I have another Scott user in DB2, and then on the database 2, and so this is the Scott of database 2. All right. So this is a scenario we are discussing about, and now we are connected to this database 1, and then whenever we are doing select star from T, we are getting whatever the data in the table T we have in the database 1. Then there is another way that while you are connected to database 1, you can still access the table T2 of database 2 by by using a object called database link. Okay, so, so something called database link. So the goal here is not to explain you how this thing, database links created and all this thing, the syntaxes, but database link is something like from this database it will tell me what is the destination database, right? And that means while I have connected to this table to this database db1, what I can do, if I do select star from T, let's say the database link name is dbl. Okay, so database link is dbl. Then if I do select star from T, then I'll get the data from this table T in the local database. If I do select star from T at a rate dbl, then I'm going to get data, sorry, T2. So T2, because this is a T2 table, right? So if I do select star from T2 at a rate dbl, then I'm going to get the data from T2. So remember, I'm still connected to this db1. Okay, but using database link, I am getting data from another table. So to extend, to what about to extend our discussion, so let's try to do some insert. Okay, so similarly, if I'm going to do insert into T, so I'm connected to db1, so insert into T, so let's I inserted a value 1. Then I do insert into T at a rate dbl value 2, sorry, T2, because the table name is T2, right? So in this thing, what I'm doing, like now, if I'm going to write this kind of statements by these two statement, let's say this is a transaction. Okay, but in this type of transaction, for this insert is happening in db1, and for the second insert, the insert is actually happen in db2. That means this transaction is distributed over two databases in our case. Therefore, this is called a distributed transaction. Okay, so now after I do insert into T1, insert into table T2 dbl, then if I do a commit here, same type of commit that you do if your transaction is happening in the single this thing, then it will make sure that all these things will be done. That means this commit is a little bit of different than the commit that we do in the single DB. Like if my transactions are only in one database, then that kind of commit is a little bit different than the commit that we are doing here. And this commit, but the syntax is same, but Oracle is going to internally implement a protocol called two-phase commit. Okay, so using two-phase commit protocol, Oracle will make sure that either this transaction completely will succeed or is going to fail. That means either you know in this database table T is going to be modified, updated with the value new value 1, and in this table T2 is going to be have insert, we are going to insert a new value 2, right? So now let's understand what is a two-phase commit. So one thing that you need to understand, that whichever database started the commit, so in this case DB1 is going to start the commit process, that is called the coordinator. Okay, so the coordinator is where the commit is actually being given, and the other databases are called participants. So in this case, database 1 is coordinator, database 2 is participant, right? So whenever the commit happens, database 1 says that okay, I'm prepared to commit. Then in the phase 1, it will send a message to all the databases which is the part of this transaction. In this case, only the database 2 is a part of this of this transaction. Then this will ask, are you ready to commit? Okay, so the phase 1 is the preparation phase, where the coordinator is going to start to ask all the participants if they are all ready to commit. If either one of them is says that no, I cannot commit, then we'll roll back the complete transaction. Okay, so the phase 1 is that the question to be asked, or that is called a voting. Okay, so voting will be done, and then are we ready to commit or not? If one of the participants says that is not ready, then the complete transaction is going to be aborted. Let's say all of these participants says back that okay, we are ready to commit. Then phase 2 will be is the commit phase, when the redo log writer is going to write to the online redo buffer. So whatever we explained in our couple of two videos before, that whenever the actual commit happens, how the commit what is the process of commit. So all this is going to write, and then all of them is going to give them back acknowledge that commit is complete. Once the coordinator is going to receive that commit is complete, then coordinator is going to send back to the SQL prompt wherever I say commit, that commit completes. This is essentially how this two-phase commit works, and it's essentially a very complex algorithm, and we are not going to discuss all those things here, but that is how this two-phase commit works. And also it may happen that after the phase 1 in the preparation stage, everybody says that we are going to commit, but for whatever reasons, one participant, the network link from this coordinator to the participant is disconnected, and the coordinator never gets back that actually that remote database has committed or not. So in that case, next time, this is a in doubt transaction, and next time whenever we're going to start the instance, the reco process, if you remember, the reco background processes is going to start and then resolve this in doubt transaction and complete the two-phase commit. Either it will commit or it's going to do a rollback.